Yes.
Yes, sir.
Yes, sir.
Okay, fine. Thank you. So in our last class, we discussed about the applications of stacks. Okay, so what there are four categories of means four application categories are there for stack: parsing, then sorry, yes, reversing the data, parsing data, postponing data usage, and backtracking. Okay, in that we discussed about the postponing data, and we discussed about two applications of stack. That is converting the given infix expression to postfix notation and evaluating the postfix expression. And for these two applications, we discussed about algorithm also. So today we will start with the C implementation for these two applications. Okay, so here is the C implementation. It is okay. So I hope this is visible. So this is the infix to postfix notation, the function. Okay, for this function, we are passing infix expression. Okay, so here I have declared one array postfix. So whatever the given infix expression, I am going to convert and store it into postfix array. Okay, and data to read each and whenever we are popping from the stack, that data, that value I am going to store it in this data variable. Okay, first I am creating a stack, then I am reading characters one by one from the infix expression until I reach the last character of the infix expression, that is null character. And first thing is I am checking whether it is a operand. If it is a operand means no need to store it into stack. Directly I can copy it into the postfix expression. So that is what we are doing it here. So infix of I am moving to postfix of k. Okay, directly copying to the postfix expression. Else if it is the open bracket. Okay, so what is the meaning of open bracket means? Suppose in an expression, okay, so here let us take this expression. So a into b plus c into d. Okay, if you are taking this expression, the multiplication operator within the bracket have higher precedency over the outside multiplication operator. So this operator must be compared only with the operators which are available within the bracket. Okay, so that is what the correct way. We should not compare this the operator which are within the bracket with any of the operator outside the brackets parenthesis. Okay, this is not the correct way. So what we are doing means so within the bracket whatever the values or whatever the operators we push into the stack, that we are popping and adding to the output expression until we find a closed bracket. Okay, so that is what here we are doing. Okay, so apart from the plus minus division and multiplication operator, we are considering open parenthesis and close parenthesis also here. Okay, so that's why I'm checking if it is an open bracket, push it into the stack. Okay, and if it is a closed bracket, what we need to do means all the operators from the stack we need to pop it, okay, until we find a closed bracket. Okay, all operators we need to pop from the stack and attach to the postfix expression. Okay, close bracket. Suppose okay, after popping it, we need to remove the close bracket also. So the close bracket, we are removing it in this else block. Okay, so here the purpose of this if block is okay, until if it is a close bracket, all the operators from the stack will be removed and added to the postfix expression. And finally, this close bracket must be removed from the stack. Okay, suppose there is no close bracket means it is an invalid expression. Means you have a you have a close bracket, but there is no open bracket available in the stack. Okay, so it is a invalid expression. Okay, suppose the open bracket found means it will be popped out, removed from the stack. Okay, so if you are finding a closed bracket, if you're first time when you are finding the open bracket, push it into the stack, and after that whatever the operators coming after the open bracket, everything must be pushed. That operation we are doing it here. Okay, and suppose if you are finding a closed bracket, until you find an open bracket, okay, all the operators from the stack must be popped out and added to the postfix expression, and finally we need to remove the open bracket also. Okay, and suppose if it is not a closed bracket, the operator is not a closed bracket, then it is not, means the first is operand, it is not an operand, and it is not an open bracket, and if it is not a closed bracket, it means that it is an operator. If it is an operator, what we need to do means we need to directly push it into the stack. Suppose the current operator has a higher precedency than the top operator, stack top operator, then we can push it into the stack. Otherwise, until we find a lower priority operator, all the operators we need to pop from the stack, okay, popping out and adding to the postfix expression. Okay, so this algorithm we discussed in our yesterday's class. Okay, so once we read all the characters from the infix expression, finally, okay, if stack is still not empty, all the operators from the stack we need to read and add to the postfix expression. Finally, we are storing, means displaying the postfix expression. So this is what the algorithm we discussed in yesterday's class, and this is C implementation. Okay, so if you are checking here, see here, whatever the code I have used for structure, okay, means we discussed one stack for the reversing of the string, given string. The same stack code I have used it here. Only one modification I did it in this code, that is a stack top. Okay, so in that program I passed two parameters to get the top of the stack. Okay, just for simplicity purpose, I simply I did some small modification here. That is, I am the return type I changed it to character, and directly I am returning the top data. Whatever the node pointed by the stack top, it's the data I am returning. Okay, so this stack top function alone I modified little bit. See here in stack 1, stack top, here we are passing two parameters. Okay, means the top data I am storing as a reference in the, means I am storing it in the reference variable. Okay, instead of that, here I am returning the stack top data. Okay, so this is the little modification I did it. Rest of the functions, is empty, stack top, push pop, all these codes are same as the previous program. Okay, the stack so string reverse program. Okay, so the same program I have taken, and I have added two more functions. That is operand. The purpose of this function is to check whether the whatever the character we are reading from the infix expression, whether it is operator or operand. To check it, means here we have created a function called is operand. Okay, if it is an alphabet, it is an operand. That's what we are checking it here. Okay, if it is a small letter A or capital letter A, it will return true. Otherwise, it will return false. Okay, then to check the precedency of the operator, here we have created one function. Okay, integer precedency. If it is a plus minus, means its precedency is 1, and multiplication division means 2, and power function means 3. Okay, cap symbol, it is 3. Otherwise, return -1. Apart from this, any of the value characters are included in the infix expression, that should not be processed. So -1 returning here. Okay, now from infix expression, means in this function we are calling this is operand, precedency, push, pop, is empty, all these functions we are calling in the infix to postfix. Okay, so checking it is a operand. Okay, then push operation, and then pop operation, all these functions we are using in this infix to postfix function. Okay, now let us check the output of this program. So here we have given a plus b into c. Okay, a into b plus c. Okay, let us check the output. See here, a into b plus c means ab into c plus. So this is the expression. Suppose if I am giving the input as a plus b into C. Okay, then what will be the output? It is a ABC into then plus ABC multiplication operator and plus. So B and C must be multiplied and its result must be added with A. Okay, so this is what converted postfix expression. Okay, let us check one more example given in your book also. Okay, so in the stack applications, so the expression given is A plus B into C minus D divided by E. Okay, let us check this expression also. A plus B into C minus D divided by E. Let us check this expression. Okay. Here we got the output. Okay, so this is what infix to postfix expression conversion. Okay, infix to postfix expression conversion. The same way evaluating postfix expression. So evaluating postfix expression also, whatever the code we used in this infix to postfix, the stack code, okay, push operation, pop operation, create operation, and all these functions are same in this program. The structures that we used, everything is same. Only the actual function, that is evaluate postfix. Instead of infix to postfix, here evaluate postfix function. So this algorithm we are using it here. So it's a code. Let us take it. Now this is the code. So the first thing is we are creating the stack. So we are creating stack. After creating stack, we are reading character by character from the input expression. Okay, and if it is a digit, we need to push it into the stack. Digit means, what is the meaning? It is an operand. So if it is an operand, we need to push it into the stack. Okay, otherwise, suppose if it is an operator, we need to pop two data. Okay, two element, two times we need to perform pop of data 1, pop of data 2. Data 1 is value 1 and data 2 is value 2. Then based on the operator, okay, based on the operator, okay, ith character is operator character, that's why we are performing the pop operation. So if it is a plus, we are performing the arithmetic operation plus and then storing it into the stack, okay, the result. So we are repeating it until we reach the last character of the expression. Okay, last character of the expression. So this is what evaluating postfix expression, and it's a C implementation. Okay, now let us compile it, execute it. See here, 246 plus into. Okay, so 4 6 must be added. 4 plus 6 is 10. Then 10 is multiplied with 2. Finally, we are getting the result as a 20. Okay, so this is evaluating postfix expression. Here the assumption is the operand is always one single digit. Okay, we are not considering the two-digit values. Okay, 20, 40, that is not considered here. Suppose if you wish to consider if you wish to do means, then for that we need to add little more logic. Okay, so the length of the operands we need to find, or we need to get value for each of the operand. So the expression, in the expression we have to use the variable names A plus B into C. Then we need to get value for A, B and C, and while evaluating we have to use the values of the variable A, B and C and calculate the result. So this is what we need to do it. Okay, so that is little bit difficult. So here our assumption is the operand size is a single digit. We are considering only the single digit values in this evaluation of postfix expression. Okay, so these are all the two applications of stack: infix to postfix and evaluating postfix expressions. Okay, now I will share these two codes in Google Classroom. Please go through these two codes and try to execute it. Okay, so next 15 minutes is for practice. Please go through it. Okay, if you have any doubt, then come back by 3:45. Okay, I'll wait till 3:45. Okay, please practice this program, and if you have any doubt in this, let us discuss about it after 3:45.